Uh, Hello everyone. Let's continue chapter 3. Let's do a problem regarding binomial distribution. A sample of vapors, 10% of chance of getting pollutant. He has given the success is 10%, that is 0.10, and where Q equals to 1 minus P, that is 1 minus 0.1, that is equal to 0.9. Samples are N equals to 18. First one. He has given, he wants to know that exactly 2 contains the pollutants. There are 18 samples. Out of 18, there are some pollutants. Out of this, he has given the probability of getting a pollutant is 0.1, that is 10%. So he wants to find out that probability of exactly 2 pollutants, that is P of X equals to 2. We know the formula by binomial, like why binomial? The condition is either success or failure. It is a Bernoulli trial. That's why we have taken binomial distribution. So he wants to find out exactly 2. We know that binomial distribution NCX P of X Q power n minus X. So 18C2 0.1 0.9 18 minus 2 16, that is, this is quite simple, and determine the probability that at least 4, that is it starts with 4. So we have to find out 4, 5, 6, 7, 8, and so on up to 18. So it is very difficult to find out for at least problem. So it's simply 1 minus P of X less than 4. So 1 minus P of X equals to 3, X equals to 2, X equals to 1, and X equals to none. So substitute formula 18C3 0.1 power 3, 0.9 power 15, like 18C2 0.1 power 2, 0.9 power 16, plus 18C1 0.1 power 1, 0.9 power 17, and 18C 0.1 not 0.9 power 18. After calculating, you'll get 0.098. This is at least problem. And he has given a range P of 3 less than or equals to X less than or equals to 7. It's quite simple. P of X equals to 3, P of X equals to 4, X equals to 5. Just simply substitute each X values. Here you'll get 0.625. This is problem regarding binomial distribution. Binomial distribution, when we can apply binomial distribution, if the trial is Bernoulli. There are few conditions in Bernoulli, like either success or failure, and with replacement. Next, now we'll look into non-Bernoulli trials. What is Bernoulli trial? We have seen that, and now non-Bernoulli trial. It's like a trial in which probability of success P. Here also there is a success P and failure Q, which will happen subsequent trial. Subsequent. Like it is like dependent on previous one. Dependent trial. That is P and Q are dependent. So it requires memory. So it depends on how, like the outcome of the previous one. We know that for Bernoulli trial, we apply binomial distribution. For non-Bernoulli trial, we will apply hypergeometric distribution. Dr. Fred Tayari has given some formulae regarding hypergeometric distribution, like f of x is equals to capital KCX n minus KC n minus x whole divided by NCN. where P equals to K by N. And this is, we know that for every distribution, we have three. One is f of x, e of x, that is expectation of x is NP, and variance is NP, N minus P into correction factor. Correction factor. What is correction factor? N minus N by N minus 1. I don't know this formula. I never remember this formula. I have a technique to find out hypergeometric distribution. I'm going to do now. And but better to remember in exam point of view. When I was in 511, we got a problem regarding hypergeometry. He has given directly K values, N values, and N values. Simply he has given some, so we need to substitute these values in the formula. So it is better to remember this one, and I'm going to teach you in different approach. I'll teach you in both, like f of x, e of x, v of x. Let's do this problem using Dr. Fred Tayari approach, and later I'll teach my approach. A production of 180 manufactured parts contains 50 do not confirmed. 2 parts are selected at random and without replacement. We can simply say that without replacement, because with replacement is Bernoulli literal, whereas without replacement is non-Bernoulli literal. So we should apply hypergeometric distribution. What is the probability that both parts conform? One part doesn't conform, both are not conform. There are three sub questions inside. So N equals to 180, K equals to 50. So in the like N equals to 2. 2 means K is what we are considering. We are considering do not confirm, remember, and N equals to 2. That is how many parts you are going to take it out. So N equals to 2. So from formula, N minus K C N minus X divided by N minus N. 50 C0. There like 8 out of 850, there are 850, right? So N minus K, 850 minus 50 is 800 C2 divided by 850 C2. We'll get 0.886. So similarly, P of X equals to 1, that is 1 is confirmed. 50 C1, 800 C1 by 850 C2. This is 0.11. P of X equals to 2, that is equals to 50 C2, 800 C0 divided by 850 C2, that is 0.003. So we know that P equals to K by N, that is 50 divided by 850, that is 0.058, and we know Q equals to 1 minus P, 0.942. And there is a correction factor C of N minus N by N minus 1, 850 minus 2 by 850 minus 1, something 848 divided by 849, it's around 99 point something, almost 99%. And mu equals to NP, similarly as binomial, 2 into 0.058, 0.1176, and variance is NPQ into correction factor, 2 into 0.058 into 0.942 into 848 by 849, 0.19, so 0.109. So this is how Dr. Fred Tayari has taught in the class, but I don't know that formula. I'm going to teach a simple technique regarding hypergeometric distribution, which will help you in the examination. So simply write 850, the total. Out of 850, I have 800 confirmed parts, 50 non-confirmed parts. Okay. Out of 850, there are 850 parts. Out of 850, I'm going to draw 2 parts from 850. So 2. Okay. That's it. The first question, what is first question? Both parts are confirmed. That means this part, this half, the right part. So out of two, both are confirmed. Like this is 50 parts are do not confirm. So this is do not confirm. Is it confirm? Okay. Do not confirm. Here, what is the problem? Both are confirmed. So both are confirmed. Or else first I'll do anything is fine. It's like first one is both are confirmed. Both are. So I have taken two from 850. Out of two, both are confirmed. So I have written on left side. Out of two, it remaining two. So now simply write C, C, C. First, we need to write this one 800 C2 into 50 C0 out of 850 C2. That's it. Same we got here. Something around 50 C, and so here 800 C2, 50 C0. Same using the formula. Simply, I'll teach you again. Like there are 850. Out of 850, I have taken 800 confirmed, 50 or do not confirm. I have taken two. One is confirm, another one is confirm, another one is do not confirm. Simply write C, 800 C1, 800 C1 into 50 C1 divided by 850 C2. That's it. We will get same. And finally, out of 850, there are 850. 2 has drawn from 850. Out of now 0 both are do not confirm. That's it. C, 800 C0, 50 C2, 850 C2. That's it. Very simple technique, hypergeometric. You can do any type of problem using this formulation. So better to remember, like as I said before, sometimes he has given n value, k value directly. So this is n, the center value is n, this is small n, and this is k. Obviously, this is n minus k. So out of this, what is correction factor? N minus k divided by n minus 1. You can simply substitute. Better to remember the notations. So I have experience regarding this problem that he has given the directly k equals to something, 2 equals to something. We have a formula in cheat sheet. So directly we can put in the formula. Very important distribution, that is Poisson distribution. And many people have exam tomorrow regarding Poisson distribution in our operation research. Every time I told you that every distribution has a keyword. Based on that keyword, we can find out which distribution is that from. For Poisson distribution, you can see an average value. A value something like per minute. Something in unit will be like something divided by some unit. So you can easily find out Poisson distribution. You can see as average value. So Dr. Fred Tayari has used some different notations. So notations is different, but I use my own different notations. So let's see. Remember, lambda is number of occurrences. I think he has given, he has taught alpha. Number of occurrences per unit time. Lambda is number of occurrences per unit time. and t is unit of time, number of units or unit time. So there is something called alpha, Poisson's parameter, that is alpha into t. Simply multiply these two, you will get number of occurrences, that is Poisson's parameter. F of x, E of x, and V of x. Let's see these three formulas. Lambda t power x into e power of minus lambda t x factorial. So both are same, lambda t, lambda t. Here, what is the difference? I think I don't remember how he has used. I remember alpha power x e power minus alpha by x, something like that. Or else he might use lambda power x e power of minus lambda by x, where lambda is equals to alpha t. Might be he has used some different notation, but the condition is same. You need to multiply these two, lambda into t. This is called Poisson's parameter, power x, and e power of minus lambda divided by x factorial. So lambda into t is mean. Similarly, variance is also same as lambda into t. Let's do a problem. So flaws occurs at random length of copper wire. The average number, as I said earlier, average is the keyword for by Poisson distribution. Average number of flaws is 2.3 per mm. This is also a keyword, per mm, something. Okay. So what he has given per mm means lambda, not alpha. Sometimes he'll give alpha directly, like 2.3. Directly he'll give alpha. Careful, please read carefully what he has given. In the class itself, he taught, like sometimes he taught directly alpha value, sometimes he taught a lambda value. So you need to observe the unit, like if he has given per mm, that means lambda. Straight away write 0.3 per mm. So exactly 10 flaws, that is equals to x equals to 10, and 5 mm in the wire. So time is equals to 5 mm. So another important observation is division, like here per mm, definitely time t value will be in mm. So after cancellation these two, you will get number of occurrences. So lambda equals to 2.3 t. We know that p of x equals to 10, that is equals to lambda t power x e power of minus lambda t x factorial 2.3 into 5 power x e power of minus 2.3 into 5 whole divided by 10 factorial, that is equals to 0.1129. So we know that expectation of x, v of x both are same, that is lambda into t. What is lambda? 0.23 into 5, you'll get 11.5. So in real meaning, it's like I remember one problem in first semester exam 1. He has given a problem regarding number of accidents occurs in a Monday or Wednesday. He has given like 5 accidents per week. So he has given a lambda value, he has given t value. Simply we need to substitute lambda t and we need to find out the mean. I don't remember the exact problem, but very important problem for your examination point of view. Like it is very simple. Like he'll change, like instead of p of x equals to 10, he'll give at least 4. So it is difficult to find out 4, 5, 6, so on. So just p of x is less than 4. That means p of x equals to 3, 2, 1, and 0. That's it. He'll change only this kind of, like at least 4, at most 4. It will start with 1, something like that. This is Poisson's distribution, very simple distribution. There is a small concept regarding Poisson approximation to binomial. Here sometimes binomial, you can understand these concepts when, if you are industrial engineering, you can find out this type of problems in future, like in production planning control, regression. Wherever you go in industrial engineering, you can find out these type of approximations. Sometimes it is very difficult to find out using one distribution. Instead of one distribution, I'll calculate in another distribution in approximate way. So For example, you take binomial distribution. Binomial distribution has a lengthy formula ncx p power x q power n minus x. So sometimes it is very difficult to find out 100 samples, 200 samples. So at that time, instead of using binomial distribution, we can use Poisson's distribution. But you will not get exact value, but it is an approximate value. So Poisson's, there is a condition if n is greater than 20 and np is less than 5 or nq is less than 5, then we can approach Poisson's distribution. So these two is the condition. These are two conditions. N is greater than 20. That is, number of samples should be greater than 20. So, for example, there are 21 trials. Out of 21, he wants to find out at least 10. So it is very difficult to find out 10, 9, 11. So 10, 9, 8, 7 up to 0. So instead of using a long procedure, we can use Poisson's distribution. Like let's take an example. A factory packs into 100 watts. You can use this technique sometimes. Like I use it to do this technique when he wants to find out a question regarding binomial distribution. Sometimes it is very difficult to find it because we will get a MQC question. So I use this Poisson's distribution. I find out the answer. The answer will be like 0.5 plus or minus 0.5. So directly we can try this technique if you are from industrial engineering. So a factory packs candy bars into 100 bars. There are 100. So n is equals to 100 bars. Probability is broken is p equals to 0.025. So definitely q is, I think we don't require q in this problem. So has 5. So out of 100, we need to find out 5. It is very difficult to find out. So what are the two conditions? One is n greater than 20, yes, and np that is equals to 100 into 0.025 or 2.5, it is less than 5. So both conditions passed. P of x equals to 5, 2.5 power 5 e power of minus 2.5 divided by 5 factorial, that is equal to 0.0668. So this is, we use Poisson's distribution. What usually do for binomial distribution? NCX q power n minus x, that is 100 cx, 0.025 or 5 q power 97590 power 95. So this is the major issue to find out. So 0.06635. It is very similar answer. So this is chapter 3. A quick review. Let's see what we have studied chapter 3. In the previous class, we have seen probability distribution, how it is distributed based on the random variable, determining all possible probability values in a form of a table or a function. It is like discrete probability distribution, continuous probability distribution. So there are few discrete probability distributions. I'll write a keyword here. For binomial trial, we apply Bernoulli trial, we'll apply binomial distribution. What are the keywords for binomial? Failure or success. Either success or failure, or yes or no. This is the keyword. Whereas geometric distribution, it is like until first success. Until first success. Or it's like before success. These are the these two are some keywords to identify geometric distribution. Next, negative binomial distribution. He'll give until rth success. Until rth success, like up to third, he'll give up to third success, before fourth success. So he'll give rth value for negative binomial distribution. These two are same. Hypergeometric distribution, this is for Bernoulli trial. I'm sorry, non-Bernoulli trial. For non-Bernoulli trial, we can directly identify because it is without replacement. Without replacement, like there also success failure, but without replacement. without replacement. So we have a formula like 850, 850 out of 800, 3 means out of 3 of one kind, 800 C3 into 50 C0 divided by 850 C3. Very simple hypergeometric distribution. And finally, Poisson's distribution is like average value per quantity. These are some important keywords to identify probability distribution. Why I'm stressing probability distribution? Definitely you'll get 10 to 20% of questions to identify distributions. I was shocked when I was in exam 1. There are 20% of questions are from identifying the distribution. He'll describe the situation. Out of he'll describe the situation. We need to find out the distribution itself. That's it. He'll give 4 options which distribution is from. I have seen 5 to 6 questions out of 20, 25. And something like PDF and CDF. Simply PDF means equals to, CDF is less than 1. And this is very best example I have given in previous class. Mean, variance, some problems with, and discrete uniform, and Bernoulli trial, binomial distribution, geometric distribution before success, negative binomial, I have seen binomial, and hypergeometric, finally, non-Bernoulli, Poisson's distribution. That's it, Poisson's. That's all. Third unit is very easy comparatively for. If you have any questions, let me know. Till we have 10 to 15 minutes. Any questions? Stephen or Jafar? Only 2 people.
Hey Vishwa.
Yeah.
So on March 6th we have exam 1. So is it 6th?
Okay.
So that is coming Monday. So is there any possibility that you can cover the chapter 4 in the coming week? Like can you arrange the class or something?
I have exam on March. Tomorrow I have an over exam.
Okay.
Okay. Let me stop the recording.
Okay.